Another follow-on question that can be asked when involving the definition of the derivative is they define the equation of a tangent line to a graph at a given point. The thing to keep in mind here is, what do we need to determine the equation of a line? Well, there are a few ways to do this. You could use 2 points. You could use the slope and the intercept. And the one that's of most interest to us right now, you could use the slope and any point on the line. Why is this the most interesting? Well, because we know how to get these two things already. If we want to look at the tangent line to the graph of f at a point x equals a, well, what do we know? Well, we already know a point that is on this line. We know we have the point that is at a f of a is on this line, because if the line is going to be tangent to the graph, it's going to have to touch it at that point. But now we have a way to also find the slope. The slope is given by the derivative of f at a, which we can compute by our limit formula. Once we have a point and a slope, we can then write out the equation of the line that is tangent to the graph at this point. And the easiest way to do that is in point-slope form. Let's see this in the context of an example. I want to find the equation of the tangent line to the graph of y equals x squared plus 3x minus 2 at x equals 1. So let's first look for a point that is on this line. We know a point on this line is going to be 1, and f of 1, where f of 1 is if I plug 1 into here, and f of 1 is going to be 1 squared is 1 plus 3 minus 2 is 2. We know the point 1, 2 is on this line. What about the slope? Slope is found via the derivative, which we compute as limit h goes to 0, f of 1 plus h minus f of 1 all over h. I can now plug in what f is. Limit h goes to 0. I have a 1 plus h squared plus 3 times a 1 plus h minus 2. And I know f of 1 is 2. I just did that step up here. So this then becomes minus 2 all over h. I'm going to expand out all the terms on the top. The quadratic becomes 1 plus 2h plus h squared plus 3 plus 3h minus 4 over h. We'll see, as expected, the 1 and 3 combine to cancel this 4, meaning I am left with limit h goes to 0, 5h plus h squared over h. I'm able to cancel an h from every term to get limit h goes to 0, 5 plus h, which equals 5. Therefore, my slope is 5, and the point is 1, 2. So I can write the equation of the tangent line from that. Y minus 2, that's the y coordinate of the point I know is on the line, equals slope times x minus 1, the x point that's on the line. And that's how we can get the equation of the tangent line to a graph using this limit definition of the derivative.